Hi, students. I recently purchased a webcam and I wanted to actually try it out for problem solving. Doing the problem solving on the computer with a stylus pen is kind of challenging, especially because I'm not the neatest person. So I wanted to try to mimic board work um, as in the classroom as much as possible. I still have whiteboard, and if you come to office hours, I can do a ton of whiteboard work and problem solving with you. But during the lecture videos, I'm lecturing on a PowerPoint and it's not quite the same. But again, I do have whiteboard. Come to office hours, we can do tons of problem solving. But what I also want to do is take advantage of now I bought this webcam and maybe every once in a while just do some problem solving for you guys using a webcam and just pen and paper. So I'm going to switch over to that right now. And kind of let it adjust. And I wrote out a problem here, and I would show you how I would approach this problem. So how many pennies are needed? And they tell you that the penny's diameter is 2 centimeters. How many pennies are needed to stretch from the earth to the sun? Okay, so you can think of it as here's your sun, over here's earth, and you want to know how many pennies. We want to know that distance, okay? So how many pennies are needed to stretch from the earth to the sun? Well, we need to know what the distance of the earth is. So this is where the second part of this problem comes in. It takes 8 minutes and 20 seconds for light to travel to the earth from the sun at a speed of 186,282 miles per second. So I love this word problem. This is dimensional analysis at its best. If you've taken preparatory chem or any chem in high school, you cover this quite a bit. I know I cover this in preparatory and introductory chem a lot. So now in G-Chem, you're getting hit with these problems and you still have to know how to do your dimensional analysis. You have to know how to use your word problem solving skills and your conversion factors, and you need to be familiar with the metric system and converting from our English system to the metric system. That's basically why I picked this problem, because there's quite a bit here. So with the 5 basic problem solving strategies that I talked about in my earlier videos is, 1, you want to figure out, what do I want? What is it that this problem was asking? It's giving me a lot of information, but what is it asking? Well, that's pretty easy. The how is what helps me. It's asking me the number of pennies. So I want to know the number of pennies that it takes to stretch from the sun to the earth, okay? Now, what is given? This is where it's difficult. This is where it's hard to figure out because you're given so much information, okay? Now, in my video, I talk about if I don't end in a conversion factor, I don't want to start with a conversion factor. So an example of a conversion factor would be miles per second, okay? If I was given miles per second and they want me to convert that to miles per hour, then I could start with miles per second and go towards miles per hour. I'm not given a conversion factor. I don't want a conversion factor. I just want pennies. So the trick is, don't start with a conversion factor. The conversion factors are just there to help you get there. So now I have to read all of this and figure out what is a conversion factor and what's not. So how many pennies are needed? Okay, and they're telling you that 1 penny, okay, is 2 centimeters in diameter. So that's actually a conversion factor, right? 1 penny is 2 centimeters. So they're doing objects and length. So we're not going to start with that. That's probably going to be our last conversion factor to get to pennies. So then I keep reading. It takes 8 minutes and 20 seconds for light to travel to the earth. So they're giving me time and they're giving me a rate. And with time, if you remember distance equals rate times time, we could figure out this distance because I know I travel, 186,282 miles per second. If they give me time, I can figure out how many miles that is. And then I could eventually convert that into the metric system and use centimeters. So right off the bat, I figure out, oh, what's given is time. Time is going to allow me to convert to the number of pennies. Now, the tricky thing is they give me 2 units for time. They give me minutes and seconds. But if I look at the conversion factor of time to distance, it's in seconds. So it'd be advantageous to convert the time all to seconds. And I'll do that in a minute. But now that I know what I need to do, I can kind of strategize. I can go from seconds to miles. And that's great. I have miles. Now, that doesn't really help me because what I really need is I got to convert this distance into centimeters. Because if I know how many centimeters are in that distance, I can divide that distance by 2 centimeters to figure out the number of pennies. So I have to convert miles into the metric system. Well, I know that miles goes to feet because there's 5,280 feet. I know feet can go into inches, and the inches are the bridge that I told you to know for length. That 1 inch is 2.54 centimeters, can go to centimeters, and then my centimeters can go to the number of pennies. So the first thing is I got to make sure that my units of time all agree. So I have 8 minutes. 8 minutes times, really, there's 60 seconds in a minute. And I could have done this in a conversion factor, 1 minute, 60 seconds. Minutes cancel. 8 times 60 is, what is it, 480. So I have 480 seconds. And then I have another 20 seconds because it said 8 minutes and 20 seconds for total time. 8 plus 20 is 500 seconds. So now I have what I initially start with. So I start with 500 seconds. I'm not going to worry about conversion factors to the very end. 500 seconds. I know that there's 1,800 or 186,282 miles per second, right? I'm trying to get used to this. And then from miles, I know in 1 mile, there's 5,280 feet. So now I went from miles to feet. And then I know in 1 foot, there's 12 inches. Okay, so far I'm still in our English system. One mile, 5,280 feet, 1 foot, 12 inches. But now I use the bridge between our English system to the metric system. 1 inch, 2.54 centimeters. That was the bridge I told you to know for length. There's other ways to do this. I'm just doing the long way. And then I know that each penny is 2 centimeters per 1 penny. And that's one clean swoop. The unit of seconds cancel, the unit of miles, the unit of feet, the unit of inches, and the unit of centimeters, leaving me with the number of pennies. I love dimensional analysis because you let the units help guide you to the answer to cancel out and get you to the correct answer. Now, the last step, right? So step 1, what do you want? Step 2, what is the given? Step 3, strategize. Step 4, I call the download dump with all the conversion factors. Step 5 is you're going to actually calculate it, and then you're going to put it to the right sig fig. So I'm going to grab my handy dandy calculator. 500, do it all at once, times 1,000 or 186,282, right? Sorry, the light in here is poor. Times 5,280 times 12 times 2.54 divided by 2, because now and the denominators of all the conversion factors, the only number is 2. That equals, okay, and that's a huge number. I'm going to write everything out. It's 7.4948 times 10 to the 12. Now, what I want to do for the very end is I want to put the correct number of sig figs, and I want to put the correct units. So that's easy for units. This is the number of pennies. It's the only unit that wasn't canceled, and it was what the problem was asking me. But for significant figures, where am I going? Well, for significant figures, remember, if you're bringing in conversion factors like 1 mile is 5,280 feet, don't use that for sig figs. Go into the problem. So this particular number has 6 significant figures. This one has 3, because those are trailing zeros with a decimal. This has 2. And then if I look, this centimeters has 2. So really, my final answer should have 2 sig figs. So I go 7.4, and then I look to the right of that 4, and because it's bigger than 5, I'm going to round up. So my final answer is 7.5 times 10 to the 12 pennies. And then I would box my final answer. Now, that's a lot of pennies, right? What is that, 1 trillion, right? Because 10 to the 3 is 1,000, 10 to the 6 is 1,000,000, 10 to the 9, 1,000,000,000, 10 to the 12 is 1 trillion. You guys know, you guys all know, because you've taken preparatory chem, that Avogadro's number is 6.02 times 10 to the 23rd. So yes, this number is huge. I wish I had $1 trillion, but it's nothing compared to Avogadro's number. And that's because in chemistry, molecules and atoms are so small, in a little bitty space, you have a lot of them. So I hope that helped. I'm going to try to use this webcam now that I bought it as much as possible to give you guys some guidance. And I hope this little session helped for problem solving and for you to complete your work this week. And again, if you guys like what you see here, as opposed to the lectures, then come to office hours. Office hours, this is what I do. I do it on the whiteboard. You ask a question, I solve the problem. Well, thanks for tuning in, everybody. And I just need to be careful because I don't want to now use a regular pen on my screen. I'll only make that mistake once. I got to remember to use a stylus. Okay, thanks. Bye.